So, boys and girls, I'm going to start another class on the basis of physics, chapter number 5. And this class is applicable for the case of student of class 9 and class 10. The name of the chapter is State of Matter and Pressure. My today's topic is buoyancy. So at first, I'm going to introduce with you what is called buoyancy. When a body is partially or fully immersed inside liquid at rest position or moving position, then you can see that that particular body will feel an upward thrust, and this upward thrust is applied by the liquid on the body and applied on the body, and this upward thrust is known as buoyancy. I repeat it again. When a body is partially or fully sink inside water or liquid, then you see that that particular body will feel an upward thrust or upward force, and this upward force is nothing but buoyancy. So you can say that the definition of buoyancy is when a body is partially or fully sink inside liquid, then this body will experience an upward thrust. Is called buoyancy. It's called buoyancy. So we can say that buoyancy is upward thrust is applied on the body. Buoyancy is upward thrust is applied on the body when you want to sink a body or partially sink a body inside liquid. You can see that ship, submarine, boat, all of the water bodies move over the water because of this upward thrust. So if there is no upward thrust is applied by the water, then you cannot move over water by using this boat, by using this ship, by using this kind of vehicle. So this movement is possible only for the case of this buoyancy force. So you can say that buoyancy is a special kind of force. Okay, so all of the force is not buoyancy, but all buoyancy is kind of a special kind of force. Now, I'm going to calculate buoyancy force. Suppose, boys and girls, this is a water container. This is a transparent water container. So, this transparent water container can contain some amount of water. I repeat, this transparent water container can contain some amount of water. So here, this transparent water container here, containing a body, a cylindrical shaped body. Suppose the name of the body is here A, B, C, D, and this body inside liquid. Suppose the upper surface of the body AB is at H1 depth inside container, and depth of the container is here H. Height of the cylindrical body is H. So the bottom surface of this container CD is at here H2 depth inside the cylindrical body. Is at what? H2 depth inside the cylindrical body. So this is at H2 depth inside the cylindrical body. Now I'm going to calculate the resultant force or upward thrust that is applied on this cylindrical shaped body inside the water container or inside the liquid container. Now, you see that the upper water from AB surface can apply a downward force. Can apply a downward force. This downward force will be called to F1. Can apply downward force, and this downward force will be called to F1. And again, you see that the water that is stay at the bottom surface of this container. The water that stay at the bottom surface of this container can also apply upward thrust on CD surface. So this upward thrust will be called to F2. This upward thrust will be called to F2. So you can say that upper part of the water can apply downward force and bottom part of the water can apply upward force. At first, I'm going to calculate the force that's applied on AB surface. Now, we can say that applied force on AB surface. AB surface, okay, is, you know that pressure P1 will be called, you know that here, force divided by area. Suppose A is the area of the cylindrical body inside the container, and F1 is the downward force, and P1 is the pressure that is applied on AB surface. Now, if you want to find out the force F1, you can say that force F1 equal to A into P1. From my previous class, you already know that. What is the value of pressure P? I repeat it again, boys and girls. From my previous class, you know that. What is the value of pressure P? You know that the value of pressure P equal to what? It is H rho G. So here A, then H1 rho into G. So what is F1? F1 is the downward force applied on AB surface. F1 is the downward force applied on AB surface. A equal to what? A equal to area of cross section of the cylindrical shaped body inside liquid is A. What is H1? H1 is the depth of the cylinder inside the water from the top surface of the water. From the top surface of the water. So here, from this particular surface to this particular surface, this depth is known as H1. And what is the value of rho? Rho is the value of density or concentration. If you take water, then rho will equal to 1000 kg per meter cube. And what is the value of G? 9.8. This is called acceleration due to gravity. Okay. So this is the force applied on the AB surface in downward direction. Now, I want to find out the upward force here. The upward force that is applied on the CD surface. You know that the applied force on CD surface. So, applied force on CD surface. Applied force on CD surface. You know that here, applied force on CD surface will equal to also from P2 will equal to force F2 divided by A. Area of cross section remains same because I'm taking a cylindrical shaped body. So in this particular case, I'm taking a body having cylindrical shape. Now, after calculation, I want to find out the value of F2. So, if I want to find out the value of F2, then F2 will equal to what? You see, F2 will equal to P2 multiplied with A2. P2 multiplied with A2. So, this is the value of F2. Now, I can say that it will equal to P2 and then it is A. So, here F2 equal to P2 equal to, since pressure P equal to H rho G. You see here, P2 is applied on CD surface. That's why at first A, then height becomes H2 rho into G. H2 rho into G. So this is equation number 2. You see that F1 is applied in the downward direction, F2 is applied in the upward direction. I repeat, you see that F1 is applied in the downward direction and F2 is applied in the upward direction. So, because of the application of these two forces, I repeat, because of the application of these two forces, this body ABCD can feel a resultant upward force because F2 is greater than F1. And that particular resultant upward force is known as, I repeat, that particular resultant force is known as buoyancy. Now, buoyancy force is denoted by F upward, is the resultant upward thrust. Buoyancy force, F upward. It will equal to here is F2 minus F1. So, F2 equal to what? F2 equal to here A H2 rho into G minus F1 equal to what? A H1 rho into G. So it is A H1 rho into G. It's nothing but A H1 rho into G. Now, I have to find out the value of buoyancy force. If I take common here, so A, if I take common, H2 minus H1, then it is rho into G. You know that? H2 minus H1. So, you see, H2 and H1. If you subtract H2 minus H1, you'll get the height of this cylindrical body. The height of this cylindrical body. Now, the height of this cylindrical body here is A H rho G. Okay. So this is the first formula for the case of buoyancy force applied on this cylindrical body. I repeat, this is the first formula applied on the buoyancy force on this cylindrical shaped body. Now, I can say that the buoyancy force, and I say that the buoyancy force applied on this body, the buoyancy force applied on this body is F upward will equal to what? Will equal to A H rho into G. You see, boys and girls, A is the area of cross section. I repeat, A is the area of cross section. H is the height. Boys and girls here, H is the height. So A is the area of cross section, H is the height. So since A is area of cross section, H is height. I repeat, since A is area of cross section, H is height. That's why A into H is nothing but volume of this cylindrical shaped body. So volume rho into G. Now I can say that buoyancy force F upward will equal to B rho G. Now, you just want to know very clearly what is this three function indicate mainly. So here, B is nothing but volume of displaced liquid. Here, V is nothing but volume of displaced liquid. Okay. Rho equal to what? Density of liquid. And here, F upward is nothing but total applied buoyancy force. Buoyancy force is nothing but total applied buoyancy force. So I can say that. So these are the total property here. V equal to volume of displaced liquid, rho equal to density of liquid, and here F upward equal to total applied buoyancy force. I repeat, F upward equal to total applied buoyancy force. Now, I'm going to calculate the value of buoyancy force here. Boys and girls, now I'm going to calculate the buoyancy force here by a practical mathematical problem. So, write down please buoyancy force by using a mathematical problem. Buoyancy force by using a mathematical problem. So on the basis of buoyancy force, I'm to solve the mathematical problem here. Suppose this is a water container. This is a cylindrical shaped body, A, B, C, D. Having water in this particular region, inside is water here. So height is h, above surface is nothing but h1, and this one is h2. Okay, downward force is here F1, upward force is here F2. Here, given informations are a cylindrical shaped body of A equal to 3 meters square and H equal to 5 meters. The value of H1 and H2 are respectively the value of H1 is 3 meter. Calculate number A, value of F1, number B, value of F2, and number C, find out resultant buoyancy force on the cylinder. Find out resultant buoyancy force on this body. Find out resultant force on this body. I'm going to find out this resultant force applied on this body. Now, my first question is here A. I have to find out the force F1 that's applied on AB surface. Boys and girls, from my previous discussion, you know that here F1 is nothing but A H1 rho into G. You know that from giving information here, A equal to 3 meters square. So A equal to what? 3 meters square. H equal to H1 equal to 3 meter from water surface. Rho equal to 1000 and G equal to 9.8. After calculation, you see here buoyancy force, downward force at AB surface will equal to, it is 3 into 3 into 1000 into 9.8. 9.8. So it is 88200. 88200. I'm going to take it again. 3 into 3 into 1000 into 9.8. It will equal to 88,200. Very good. Now, in second part, boys and girls, now in second part, I'm going to calculate the value of F2. So what is the value of F2? You know that F2 will equal to what? It is A H2 rho into G. You see here, A equal to 3. And what is the value of H2? H2 is nothing but H1 plus H. Because you see that in the diagram. You see here, this one is H1 and this one is H. So if we add H1 with H, then you will get H2. Then you'll get what? Then you'll get here H2. Okay? Then multiplied by 1000, and then G equal to 9.8. So it is 3 into H1 equal to 5 plus 3 into 1000 into 9.8. Okay, so it's nothing but 3 into 8 into 1000 into 9.8. So it is 2,35,000. 2,35,200 Newton. Question number C. In this particular question number C, in this particular question number C, we have to find out the resultant buoyancy force. Now, the resultant buoyancy force is applied on this cylindrical body is F upward. Resultant buoyancy force is nothing but it is F2 minus F1. Resultant buoyancy force is nothing but what? F2 minus F1. So here, F2 equal to what? 2,35,000 then 200 minus F1 equal to what? 88,200. It is 88,000 then 200. Okay. So the resultant force is nothing but F Newton minus 88,200 will be 1,45,000 Newton is the resultant buoyancy force that is applied on this body. Is a resultant buoyancy force that is applied on this body. So boys and girls, I'm going to give you a homework on the basis of this buoyancy force. Suppose the area of cross section equal to 2 meters square. Depth of the cylinder is 4 meter and H1 equal to 7 meter. Now, on the basis of the given data, you have to solve this homework at your home. Now, I can say that your homework is a cylindrical shaped body of area of cross section equal to 2 meters square and depth H equal to 4 meter and the value of H1 equal to 7 meter. And from this given data, you want to solve this some mathematical problem. Number A, calculate the value of F1. Number B, calculate the value of F2. And then question number C, find out resultant buoyancy force on this body. You have to find out the value of resultant buoyancy force on this body. You just solve this particular math just following this procedure A, B, C. I repeat, just following this procedure A, B, C. So that's all about my today's class. All of you, thank you very much. Thanks for watching my today's lecture.